Good evening. Welcome to IT Present Episode 3. As usual, if you are enrolled at the class, please check in by typing in the chat box about your degree program and which term you are in. And also, we welcome you watching us on YouTube. Before we get started, let's look into our agenda. First of all, I'm going to give you a greeting and warm up the room and give an introduction. It will take the first 5 minutes to warm up. Then the next 15 minutes, we'll have our academic chair, Dr. Ramesh Kanda, give us a good update from the Department of Business Administration and Engineering Management. After that, we'll have our main course. That's from Dr. Biswanath Chowdhury. So he's going to give us an exciting talk about reshaping the future using cutting-edge technology, one byte at a time. We look forward to hear about that. At the end, we'll have a question and answer. After that, we'll have a break. We make the first part together and a little bit flexible, but then we make sure we have a break by 7:20, and then we have 25 minutes for networking. So let's get into the first part. Before we get started, we'll always say, hey, our is enjoy IT Tech Talk Style series while earning your degree credit, okay? So how to present ourselves well? Let's try it. Hey, everybody, smile and sit up to the camera. So let's all turn on your video, okay? All turn on your video and say hi to each other and wave to each other, okay? So we're welcome. We see Professor Pocconi. Hi, so we wait for each other. And we see our speaker, Dr. Chowdhury. Hi. And we're excited to see our students, Renzo and Killen, right? So excited to see you. And our team, Anna, she's a designer for those beautiful posters. And today we have a new team member work on the live streaming. So glad to see all of you. Welcome. So we have a good exercise. Sit up for the camera. And most importantly, we need your attention. Listen carefully, and then at the end, we're going to ask training and intelligent questions. Yes, we always said no dumb question, but intelligent question will make you stand out in the crowd. All right? For that. As usual, yes, each time I'm going to answer one question. This is the third time. So previously I explained why we call it an episode. Because this is the concept of entertainment, okay? And we say, hey, how does this IT present different than other events? Today, I'm going to talk about, yes, it's a class, but seems like it's not a typical class. This class is split into 3 terms. So it's a little bit strange, but we have good reasons. First of all, 90% has 1 credit in total, but each term we only have 1/3 credit. What does it mean? We only have 1 every 3 weeks. Now the beauty of that is we can use the prime time entertainment. Hey, today is Saturday. Thanks for joining us during this prime time. This is your time with your family. But we're here for a bigger calling. We listen to experts from the industry for their own reflection and get inspired from them. And then we embrace the future. So this is a big calling. And it was the prime time from each of us. So, as always, after when we listen, think about these three questions, okay? Especially if you don't have a special question, think about this thing, these generic questions. What is the speaker's unique personal and career journey in Silicon Valley, right? And how does it relate to emerging technology? Think about the keywords Silicon Valley, the epicenter of innovation. And then it's all surrounded by emerging technologies. Last time the speaker gave us the history of the last 100 years, how the technology comes and goes and what stays, right? And then after that, what will be the new trend and we look forward to the future. So these are the good questions we can ask again and again. All right. Of course, for us as students, come prepared, listen intensely, and research further if you see something so interesting, right? All right. So let me transfer the screen to our Professor Kada. Okay. So I'm going to stop sharing. So Dr. Kondo, make sure you unmute yourself and share the screen. Thank you.
Hello everyone, good afternoon or good evening. I'm going to share the screen here and my slides. So give me a second here, so you'll be able to see the screen. I'm going to make it to the presentation mode. Okay. It went towards the end. So let me, okay. I think we are here. Okay, good afternoon, again, good evening. I think as Dr. Michelle said, you took out your valuable time on Saturday evening to join us, ITU Present. This is a very valuable session at ITU where we bring in the industry experts and also the academicians from the ITU. So hope you will learn a lot of new things today, and please feel free to ask any questions. I'm going to present information from the business administration and engineering management. I'm the department chair for the both departments. So welcome to the session. So I have brief information about the business administration and followed by engineering management. So the intent of this presentation is to give you an idea of some of the new things. I think most of you are aware of the program, but some of the things we always improve our programs with the new additions. So we do have new additions. Exactly what you are seeing today is ITU Presence has been there. Obviously, we reactivated, and Dr. Michelle is leading. Along with the ITU Presence, we also have the ITU Nuggets. I will come there, but before that, I will go through a brief intro about the business administration. So, the main goal of business administration is to provide foundation and skills in the business administration field. So primarily, you take a look at anything around you, including in your home. It is a kind of administration, right? Working with your family, children, yourself. Always you need critical thinking, problem solving, and communication and teamwork. So I tell in my class students, So today we say Microsoft or Google or Intel or whatever the companies are, top five, right? And if you go and ask the CEOs, the number one problem what they are facing, you will evidently hear, if not number one in top five, is the communication and the teamwork and the critical thinking. So these are all like, we are addressing here. Obviously, we may not solve 100%, but at least part of the business administration, we try to emphasize the importance of critical thinking, problem solving, communication, and the teamwork. So that is the broad perspective of a business administration program. And so we have concentrations along with the general MBA, business analytics with STEM option. And recently, as of a week ago, we introduced economics for business and development. This is a new concentration which is going to be implemented coming fall, means like in this fall 2020, right? And healthcare management concentration, financial analysis, risk management, project management, enterprise resource planning, management information systems. So we have a very broad program and with the several concentrations. So it addresses business needs from different areas. As you know, the MBA students eventually, sooner or later, aspire or expected to be leaders, right? In managers, senior managers, directors, CEOs, and heading the business organizations. So they need cross-functional knowledge, and also if they want to have some specific knowledge, for example, financial analysis or project management or business analytics. So along with the general knowledge of business, they would also learn some specific knowledge about some of the concentration areas. The other information I have is very generic. When you join the MBA program, we have what it is called inbound exam. We request all the students to take this during the first trimester. Basically, what we are testing here is you don't need to prepare for the exam. We are just trying to gauge what is the knowledge you have in the business area when you are coming into our MBA program. And similarly, when you are about to complete our program, we require you to take outbound exam, which is again testing your knowledge gained during the program, while you are with us in the ITU. So you are going to be asked to take this inbound and outbound. And the difference is what we call you potentially gain the knowledge at ITU. And one very good thing, proud thing to share is we are, the statistics so far shows the difference between inbound and outbound. Many schools does this. So we are among the, top universities. The knowledge you gain during this 2-year time frame, you study the MBA with us, and the difference in the knowledge you gain when compared to other universities, we are among the top universities. So we are very proud to share that information. So this enforces that we are no less than any other top university as far as the knowledge we gain from our institution, our professors. I think speaking of professors, I don't need to reiterate, but as you all know, majority of our professors are from the industry. That means they have qualifications to teach, like PhDs, and also very long experience in their given field, and they have passion to teach and work in academics. So the combination is the best combination what we have. So when you ask a question to the professor, they're not only thinking from the textbook version, but also they are thinking from the industry experience. As an example, myself, I'm the chair of the department, but also I work in the industry. I'm the vice president at a software development company in the Bay Area. So, and I also worked in the past in different industries. Some of them are the Seagate, which is top hard drive manufacturer. I worked at General Motors. It's also one of the top car manufacturer, and I worked at several startup companies and mid-size. So when students ask the question to me, I'm not only thinking from the academics, but also I'm thinking from the practical perspective. And I usually tell, okay, this is how we use it in the industry, and this is how it is explained in the textbook. So typically, textbooks are obviously uh, as current as possible, but industry experience is what you gain, how it is really applicable in the industry. So that is a value we bring, across all the departments, and not only business department, but take it computer science, software development, or software engineering, or electrical engineering. All of the, it's a unified theme across the ITU. So I'll quickly go through some samples of course structure. So total 39 credit hours is what we require, and you can see the core courses, capstone, ITU internship, ITU presents, nuggets. So this is a sample basically, right? I don't want to, excuse me, give you a lot of overburdened information, but just the course structure, and each department has the structure. So one example for the MBA courses are, you see the core courses, capstone and nuggets, and the internship and directive courses. So I think we have less time, but I'll focus on this one. Recently we introduced minor program. So I'll take a sip of water here. So this is across all departments, but I'm just presenting for the MBA. So you can be a graduate of computer science or engineering management. You can still take 4 courses from our department, business administration, and then you will get a degree, minor degree in the business administration. Similarly, you can be MBA student and you can take 4 courses from the software engineering, and you will get a minor in the software engineering. So this is the note we have. So you should get the prior approval from the chair, and you'll be able to pursue these. So some examples. I think I will not go a lot of details, but how the market research shows for the business administration knowledge, the market research specialist, management analyst, financial managers, business operations, general operations, accounting. So different areas we touch, based on your business administration degree. So I will, I think, quickly go to the engineering management. Same engineering management, what it does is it brings your management skills and engineering skills as a engineering management. So you can have traditional degrees, civil, mechanical, electrical, whichever areas, and it is a combination of management and your original traditional degree. So you will be called like an engineering management degree specialization. So this will give you a good management skills and also your own engineering field. So it's a combination of both we put together. Again, once you complete the engineering management, you can become a program manager, department manager, principal consultant, and all the way to the C-level executives. So, and we follow here ASEM, Association of American Society for Engineering Management. We follow what they specified, the expected curriculum, and we follow the same standards. So sample course structure, it is same. We have to do, your students have to do the 39 credit hours, three core courses, one capstone, internship, ITU presents and nuggets, and rest of them are electives. So I think I think I'll take a pause here. So any questions you want to ask? So I'll stop my sharing.
Thank you so much, Dr. Kanda. We're so lucky to have you as our new chair. I witnessed since although you're new, but since you joined, become the chair, I see so many new development from you. You work on two new concentration and now the minor. And also because our new curriculum will have nugget structure, introduce flexible core structure. And Dr. Condon even think about, under this pandemic, how are we going to respond to it? I mean, he has all kinds of great ideas. So it's so exciting to work with Dr. Condon. So I know, as you noticed, so Dr. Condon is a chair for both business administration and EM department. With, within 15 minutes, we don't have enough time, so we'll bring you back again next time, okay?
Sure. Yep.
Yeah. So let's give Dr. Condon a round of applause before we move forward. Thank you so much.
Thank you, Dr. Michelle.
All right, so next, this will be our main course for today. Let me introduce Dr. Biswanath Chowdhury. So I have the privilege to work with him to bring this talk together. And every time our team will design a poster for the speaker and for the talk. And we really like this title. He's a Dr. Chowdhury. He's a research engineer and developer in his heart, right? So when he talk about the come up with the title, he embedded a little humor in the title. Instead of one byte, B-I-T, now become byte, the digital byte at a time. So this is really good. We love it. And I'm not going to spend time to introduce you because this is a unique talk. You get to introduce yourself, okay, about your journey. So we'll transfer the screen to you. Let's welcome Dr. Chowdhury. So I'm going to stop the sharing and let you share the screen, please.
Okay. Thank you, Dr. Michelle, for the great introduction. So 1 minute, let me get my screen up. Okay. So can you see my screen?
Yes.
Okay. Yeah. So good evening, everyone. I would like to thank ITU for giving me the opportunity to share some of my work. Silicon Valley has always been the world's leader in breakthrough technologies. And today, I would like to talk about some of the cutting edge technologies which is reshaping our future. When I first started my technological journey, computers had very low processing power and storage space compared to what we have today. So computers can handle data files which were only a few kilobytes when I started, and this was a big constraint. However, over the last few decades, there has been vast improvement in the memory and processing power. Both in my personal experience and in general, these changes has made it possible to process large data files. We are talking about terabytes or more of data. This has opened up exciting opportunities to develop new technologies for a better tomorrow. Today, I will just follow the evolution of computers and some of their applications and how the technology has shaped me also. So I was very fortunate to start my career at a top engineering school in India, and this gave me a really solid background in core engineering topics and provided exposure to a lot of specialized fields. So when I joined the Institute for Engineering, this was the first time that I had access to computers, because around that time personal computers were not available widely and it was very expensive. So our institute had just got a new Cray computer and we were very excited to work on this supercomputer. But we had to work in a really cold and dust-free and controlled environment. So every time we had to go to the computer lab, we had to put on sweaters, and I used to shiver inside the computer room. Thankfully, we don't have to do that anymore. We can work from a remote terminal, and then we don't have to be in a cold environment. So when I worked on those computers, they had just phased out punch cards. I don't know whether anyone here knows about punch cards, but that's how I used to feed the program into the computer. And I did scientific programming, learned scientific programming. So some of the languages that I used was Fortran and Pascal. Pascal is no longer used, but Fortran is still used in the weather community and the air quality model community. Um, I don't know how many of you know that Fortran is still being used. So during my third year in chemical engineering, we did a project, and in that project, I learned about computer simulation. So this I learned that using computers, you could simulate a chemical process, and you could do the make mathematical equations and model the whole process, and also learned 3D computer aided design. So these projects got me interested in computers and computer modeling. Um, Once I graduated, I joined a pharmaceutical company, and as a management trainee, I did training in multiple locations. So I was very excited. We had a good curriculum, and I was very excited to work there. Um, I also remember that one of the first time that we got a personal computer, and it was a 486 computer, and it was running the first version of Windows. I remember that my colleague in quality control department was showing off a new floppy disk, uh, which could hold 1.44 megabytes of data instead of 450 kilobytes in a floppy disk. So we're talking about really small data here. Nowadays, Microsoft Word document or anything can be more than a few megabytes. So the work was very interesting, but this what I expected in the pharmaceutical industry. I realized that I was doing more of personal management than technological work. Also, for production, there was shifts, and sometimes I would work in night shifts. And uh, I don't know if people know about it, but night shifts are very difficult because it's not in the natural sleep cycle, and you cannot get into a natural sleep cycle. And I remember that I would go in there, and then sometimes standing, I would feel sleepy and as if I was going to fall down. So it was tough. Uh, I also did some research projects when I was working there. And these research projects was to improve the efficiency and productivity in the production center. So when I did the research, I decided that I wanted to be focused more on research, and that's when I thought I should pursue higher studies, and I applied for joining a graduate program in US. In US, the research field I liked was air quality modeling, and this is the area I thought I would do my doctoral studies. Um, in our group, we developed air quality model, and we were using silicon graphics workstations. At that point of time, silicon graphics was pretty famous because Jurassic Park had come out, and that's where they first started using computer generated graphics in movies. So it was exciting to have a SGI workstation in our lab. We also had access to high performance computer. This was HP, which is HP Convex computer. HP is based in Palo Alto. And again, we were using Fortran for the main program. And I was the other technology mostly I was using was Bash scripting, and I was using GNU plot for plotting. So these models we would run it, and they take a lot of computer resources. So our main task was to be able to run models for a longer time, bigger area, with finer resolution, and would like to run it faster. So the way to do it was to run the program on using parallel processing. That is where you distribute the work on multiple CPUs. So I used message passing interface, which is used in distributed memory, where you have multiple nodes which have memory, and then you share the data among these nodes, and then the nodes then work on different chunks of the problem. So it was very interesting work. Through my experience, I learned that we have to be self-motivated, and you have to learn new skills. I had basic classes in programming, but I had to teach myself a lot of the scripts, and also all API programming and all I had to learn on my own. So a lot of these advanced concepts, you did not have any coursework, and I had to learn things by myself. The other thing I learned was that it's very important to find a research group and to build a network within your university so that you can discuss your work and present your ideas to your peers. Also, we should take every opportunity to collaborate with outside groups and attend conferences and present your results, because this is how you get new ideas, and you basically improve your skills, and you can do better in your research or in your field. So after graduation, I joined a research company which developed air quality models in Princeton, New Jersey. Um, so basically, this in this case, this team was developing the air quality model using Fortran 77, and that's when they decided that we need to move to a newer version, and that we started moving the whole model to Fortran 90. So Fortran 90 has some object-oriented programming concepts in it and features in it, and that's what we were using for the model. Again, I was still using Bash and GNU plot, and these air quality models are regional models. So this is only for small areas that we were doing. So we ran these models on Windows systems or Linux systems, and they were just using high-end desktops or simple workstations. But we had some workstations with maybe multiple CPUs. So again, in this case, it is a shared memory. So we were using OpenMP, which actually uses OpenMP to distribute the work between the different CPUs, but with shared memory. We have this scheme model, which is open source, and it is available on GitHub. So actually, if any one of you are interested, they can use it or look at it if they want to. Another project which I found very interesting is source term estimation. So basically, what it does is you have a network of sensors, and these sensors will gather the air quality data, and then in real time or for analysis, you will save it, and then you can use this data along with the meteorological data to try to estimate where the pollutant is coming from and how much of it was released, and you can use it to basically determine the source. So this is where I started learning new techniques. I did some research and found about the machine learning techniques uh, that could be used to process the large amount of data that we are getting from the sensor network, and also how to use the data in the model. So I use clustering to get the sensor network data to reduce it by removing the outliers and to sample the data so that we had a smaller set, but we were not losing much information from it. So I used Python to do a lot of my work. I learned Python, and then I used it for doing most of the data analysis work. And using this method, we actually improved the model a lot. Where earlier it was taking a few hours to run the model, we could now run it in a few minutes. So it was good work. Recently, there was an article in Nature, I think it was May 2019, I think, where someone from another group used a similar technique. And here, what was happening is that someone was using CFC, which are banned because it causes ozone hole, and they could they knew that someone is releasing CFC using these banned products, and but they could not figure out where it was coming from. So they used a model similar to this, and basically they could trace that this was coming from somewhere in eastern China. So this helped that the community to basically pinpoint a specific area, and then everyone became more cautious, and there was more monitoring that people were not using these plant products. So, like everybody else, I was always fascinated with Silicon Valley because that's where, it's the happy place, and I wanted to be part of the action. Um, so I tried to get a job here in Silicon Valley, but there were limited air quality. In the field of air quality, there were very few jobs. So I decided that I would switch fields, and I decided to move to weather modeling, which is close to air quality modeling, and I could use some of these skill sets. I gave multiple interviews in Bay Area, and in one of the interviews, I was asked by my interviewer that how I communicated in my office. Um, since my office was small and we had only 5 people in there, so I replied that, whenever I want to communicate with my colleagues, I just walk over to their office and talk to them. So clearly, this was not the answer they were looking for. And I realized that I have to update my technical as well as my soft skills. So I started reading up. I started taking some online courses, and also decided to attend uh, hackathons. So some of these hackathons were technology hackathons, then some of these were art hackathons. So here, for example, there's an image of the air flower, which is part of the hackathon, where we designed an air quality sensor which looks like a flower. So it will tell you the air quality, based on what it senses. So, so I had to improve my skills, and these hackathons helped me improve a lot because I got to work with other people on a common community problem and also learn new technologies. So for data analysis, I was earlier I was using Fortran, so I started using Python. For control, I started using Git instead of CBS. For communication, I started using Slack because that's what we were using for the hackathons too. And for the methodology, I started using Agile, learned about the Agile methodology instead of the waterfall methodology. And also for organization, I started using Trello. So, so I was able to get a job in this area a few years back, and now I'm working in the field of weather modeling. So, in this job, do regional forecasting, and here also we use weather models, which can be pretty high resolution, some kilometer resolution. Uh, but we need high performance computers for running these weather models. And it can take a few hours, even with like hundreds of CPUs. So, and we generate like terabytes of data for each of these runs. So, we definitely need to process the data and analyze the data. So I'm still continuing to use those techniques that I learned, and I'm also learning new techniques so that we can identify the patterns in the data based on the regions and the season, so that we can understand the weather and be able to predict it even better. Um, I'm very excited to be part of this innovative culture, and it has been influencing the entire world. These technologies, since the start of the digital revolution, and my research and education has been shaped by these technologies from the Silicon Valley. So, so I would like to talk about some of these challenges that we have in current society. Uh, there are many new technologies being developed, and we can provide innovative solutions for these challenges. And these technologies have significant impact on our lives. So one of the biggest challenges facing our planet right now is climate change. And since we are living in California, we are all very familiar with the wildfires and drought. Recently, for example, in the campfire, when we stepped outside, we could smell the smoke outside. It has a direct impact on the air quality here, and even when we have droughts, we have a problem, with how much water we can use and for the water usage. So climate change is making the situation much worse. In addition, we have rising sea levels, and this is threatening our coastal communities here. Other communities around the world also have similar challenges, such as we have higher storm intensity, we have more hurricanes, and the air quality is becoming worse, and we have spread of tropical disease because the temperature is much higher now in a lot of these places. So to mitigate the effects of climate change, we are developing a range of new technology solutions in Silicon Valley. Some of these technologies which are being developed are new low-cost sensors. These sensors can measure temperature, humidity, pressure, and also there are new satellites which provide more improved remote sensing. So using this data from the sensor network and the satellite images, we can provide better weather and climate forecasts. So using these better forecasts, it can help us in different industries, such as we can provide early warnings for hurricanes or storms, and we can do planning for droughts so that we know beforehand, that we are going to have excess rain or droughts. And also, this is being used by the um, um, insurance industry for risk mitigation in the coastal areas. So these are some of the applications of weather forecasting. One example of the company working in this field in the Bay Area is the Climate Corporation. It has been taken over by Monsanto right now, but this company provides granular weather forecasting and environmental modeling. It helps the farmers decide what is the best crop to plant based on the soil type and weather. So they also use sensors to monitor the soil humidity and other parameters. So it helps them guide as to how much to irrigate the field or what fertilizers to use. And they use satellite images and drones to monitor the crop health. So this can help improve the productivity, and also it will reduce cost and reduce the waste of fertilizer and other products. Like when they use excess fertilizer, what happens is when you have rain or something, it goes into the actually groundwater, and then it causes pollution. So it helps everyone in this case. As we were discussing earlier, climate change is resulting in poorer air quality. So there are citizen sensor networks where people have used their own sensor, and then they have hooked it up to the network. And you can actually monitor the air quality in your area, and also, or you can go to these websites and look at these maps, and then figure out what the air quality is in your area. So knowing the levels of the pollutants, it can help safeguard the health of high-risk individuals, people who have asthma or heart problems. For example, recently there was another study which showed that when you have more pollution, then it worsens the symptoms of COVID-19. So it actually increases the risk for whoever is infected with this virus. Also, air quality affects minority communities more. So we should gather the data, monitor air quality for less affluent neighborhoods, and this can be the first step towards environmental justice, and we can use this data to improve the health and well-being of these communities. Aclima is another company in San Francisco which uses sensor, and they installed some of the sensors on Google streetcars, which collected the air quality data. These provides critical data to reduce air pollution and reduce greenhouse gas emissions. It also provides hyperlocal air quality information so that people can get engaged and take action to protect each other and their environment. I'll move to a different industry, which is the healthcare industry. So there are a lot of new technologies which are being used to transform the healthcare industry. Some of these are very common and used by a lot of people nowadays, such as smartwatch from companies like Apple and Fitbit. So they are used to improve our well-being by monitoring sleep and exercise. Other devices also are used for more specific applications like monitoring glucose and heart activity. Many new monitors can sync with the patient's smartphone, and it can help them and their healthcare provider to track the blood glucose and the heart rate for everyone. So For example, the Apple Watch can notify you if it detects arrhythmia. It can help in preventing more serious underlying issues. For example, I know someone actually whose heart rate shot up at work, and his colleagues thankfully took him immediately to the hospital, and they found the underlying cause, and doctors were able to take the corrective action. So that was really helpful. Some of the other types of modeling that we use computers for are the data-driven qualitative cell modeling, which it can help in medical research. For example, cancer cell modeling, for instance, can help reduce the cost of experiment. So it can guide the research into new therapies. Similar models are used to identify models which are more effective in vaccines, and it can reduce the uh, or it can help select the best vaccine candidate. So, for example, this technique has been used to identify some vaccine candidates for the Lassa virus. Uh, this Lassa virus causes Lassa fever, and it's endemic in parts of West Africa. So, they have identified some of these candidates using computer models that which medicine would be most effective for a vaccine, and it can reject the ones which are not suitable. So it reduces the number of products or drugs which are used for the vaccine, and reduces actual experimentation. Hopefully, we can use some of these techniques to accelerate vaccine development for COVID-19. A vaccine right now would be really helpful for all of us. We can also use computer models to track the spread of diseases. For example, in one Stanford lab, they used cell phones to record the sound of mosquito buzzing, and using this, they analyzed it and they could determine what kind of mosquito species it was. So this helped the researchers to identify which disease was most prevalent in that area. Another group at Stanford is developing a model to predict the spread of COVID-19 based on how much people are following the guidelines, and also maintaining social distancing. So this model is actually available on GitHub, and anyone can play around with the model there. Switching gears, let us talk about some of the technologies which are rising to prominence in Silicon Valley. These are innovations which are changing our lives already and have great potential to shape our future. These are only some of the technologies which I'll talk about. These are the ones which I'm interested in and I think have great potential. Now that we have immense computing power, we want this computing power to be accessible to everyone. So virtual machines and containers provide scalability and access from anywhere in the world to anyone, whether you are an individual researcher or an entrepreneur or a small business or a big company. Some of the tools developed in Silicon Valley, such as VMware, VirtualBox, Docker, Google Cloud, they help create scalable, portable, and consistent applications. Whether you're developing a weather model or a biological model, we can port these models to the cloud and make it accessible to everyone. You don't need to own your own personal computer, powerful computer to run these models. You can run it on the cloud. And based on the requirement, you can scale it up. And you can actually participate in some of these through Kaggle or some other studies which are available. So the another technology which I find very interesting and I think has a lot of potential is virtual and augmented reality. It can help visualize and understand the data from many fields. So when you can visualize the data, then you get better understanding and you can come up with a different solution. So you can use actually weather model output, or you can use it for training medical personnel, or many other applications have been transformed by using the virtual reality, such as Oculus Rift headsets. We have augmented reality where you actually can use some object in whatever location you are, and it's being used in multiple applications such as in physical therapy or in interior design. So physical therapists and patients can get real-time quantified mobility information, and they can know how much effect the physical therapy is having on the recovery. So consumers can virtually see also, for example, using Google Glass as to how a furniture fits in the room before ordering. So these are some of the things, some applications, but there are many applications which are possible. Another new field which uh, is showing a lot of promise is farm robotics. Here, multiple robots work together to achieve a common goal. Each robot can perform only simple behavior, but the swarm is able to communicate and work together. And this creates surprising and powerful new abilities. So the benefit of this technology is that no piece of hardware is very complex or essential for the swarm function. For this reason, some such technology can be implemented for applications like search and rescue, or on a smaller scale for drug delivery in the body. For example, you can use a swarm of drones to map out an area, or after a hurricane or a storm, it can use to find people who are, or you can access the damage caused by the storm. So I think they have great potential, and this is a relatively new field. The other thing is artificial intelligence, and artificial intelligence, has many subfields such as machine learning, where we provide the computer a large amount of data to identify patterns, and you can use it to predict weather or air quality for the next day, or to rapidly diagnose disease through medical images. Using artificial intelligence, you can use it for recognizing objects from a camera, or you can use natural language processing, which can be used to help translate between different languages. And robotics, of course, where you can use artificial intelligence, and you can have robots which will do some of these repetitive and dangerous work. Um, so Silicon Valley companies are increasingly turning to AI, and we already know previous speaker John. He already talked about self-driving cars. So Tesla is one of the companies which has a very popular car which has some autonomous driving in there. Similarly, we have Apple and Google working on artificial intelligence. We have Siri, which can recognize our natural language. Um, so we live in a time where each of us carries a computer in our pocket, and with increases in computing power, memory, and storage, the future of technology is evolving rapidly. And One byte at a time, technology is changing our life. And now it's your turn to be part of the change. Thank you.
Well, thank you so much, Dr. Chowdhury. The beauty of this talk is, you know, you really share your story. I mean, look at your early struggle, right? Right after you graduated, you had to work on night shift and you know technology. And then you got motivated and decided to pursue PhD uh, degree study in the US. What a courage, right? So all these things are so amazing. And then when I when I see the early tools like Pascal, Fortran, um, um, the computer, all those stuff, it's just like the, the journey you went through is the history of computer science, how it progressed, right? So I think when we go to the computer museum, it will really echo your journey, right? How it transformed. So we appreciate your story, your insight, and especially after you witness, you actually practice all the changes, and then you look into the future. Some of our points and with the potential application, I think if we listen carefully, we can even use that as a tip to purchase stock. You know, right? So this is sort of courage to listen to you. Thank you so much. Let's give you another round of applause.
Thank you, Michelle.
Thank you so much. All right. Okay, I'm going to share the screen now.
Okay.
This will stop your screen, right? Okay, I'm
Yes.
going to stop your screen and I will share that. Now, this is the fun part. Every time we got to share one quote about a question, and then we want to give the credit to our assistant, Anna. So today the quote is, the important thing is not to stop questioning. Curiosity has its own reason for existing. So what it means, okay, so when we listen to such a rich information, so you just keep asking, how could Dr. Chowdhury become like this today? And how can I become someone like him, right? You relate to yourself. So this is the curiosity. And perhaps you have some question about the future, right? I mean, self-modeling, like how to check the disease risk model. I mean, all these are so new and so relevant. So this is a time to ask questions to the speakers directly. All right? Ready? Raise the hand. Okay, we have two channels. One is the Zoom. So only students register this class when it comes to the Zoom. We call it the private invitation to our Zoom meeting. At the same time, you can also join us on the YouTube. There are 5 second delay. No worry, we can relay your questions to the speaker. So let me see if anyone you can raise your hand directly, or you can type your question in the chat. Okay, so do we have the chat? Any questions so far? So Dr. Carter, this is a great way to exchange ideas. So would you like to?
Yeah, I have a question if that does not happen. So, looks like Dr. Chowdhury and I go back to the same old age days because during my engineering, I was exposed to Fortran. That's one of the courses in the engineering class. I took Fortran programming. And funny thing was, like, I was in the mechanical engineering program, So our college just started the computer science degree when I was in the college. So we had only one computer, and it was it was in the AC room, as Dr. Chowdhury mentioned. It was air conditioned, and only people who can go and sit and program work, like the computer science student. The mechanical engineering students, we had to go and look through the window, like a glass window. It is like a museum. We have to see through the window. Oh, that is how the computer looks like. So I think, yeah, it reminds me all of my college days. So we should connect offline. Looks like we went to the engineering college during the same time frame.
Yeah.
Where the computers were new, and the air conditioning, as you rightly mentioned.
Right.
Now, literally, we carry laptop into our backyard,
Yeah.
and the temperatures, cold or hot doesn't really matter.
Right, right. Yeah,
Yeah.
we've come a long way.
Yeah, definitely reminds me all the things. So one quick question is, is the Fortran still being used, or in your view, where it is used, or is it still existing?
It's still existing. Actually, it's very popular with the meteorological area and also in air quality. So, but the problem has started is that there are very few vendors now supporting Fortran. So Fortran now, you know, we have Fortran 2000 also, which has a lot more object-oriented programming in it. But slowly, a lot of these vendors which are supporting, like Leahy is still there, but Microsoft had a Fortran compiler. They stopped supporting it. Then there were a lot of others, like the deck. I think got absorbed by Intel. So one of the main ones right now is Intel and Leahy compiler. We do have G-Fortran, which is open source, but mostly people have started using, like Python or Java or JavaScript for the web and all that. And we there are limitations to the Fortran, where you can run it and all that. But like recently, we were looking at in the previous one where we went from Fortran 77 to Fortran 90. Similarly, they were looking for whether we could change from Fortran 90 to some other language which is fast and also easy to use. But the problem is uh, you cannot speed up the code. If you compare the speeds, then the closest one is C, and C++ a little bit, but the other ones, they run very slow when you try to run all these models, similar type of equation. Like for example, I don't know whether people know it or not. Python for NumPy and all that, it's actually they use libraries which are actually Fortran or C. So that's how this have it run faster. But uh, but right now we still don't have any good replacement for Fortran. So hopefully we'll have some other language come up which will be easier to use and faster.
That's good. Good to know the insights. In fact, I'm just going back to the replacement of programs. Right, we have the mainframes,
Right.
and it's been embedded into many large systems. Right, in the banking, healthcare, government
Right.
program. And recently, even the New York, like in the pandemic situation, I saw a news, some appeal from the government asking for the people who knows the mainframe because they needed some help, I think.
Right, right. That was the COBOL, right?
A bit, right? Okay,
Yeah,
yeah.
they are looking for people who know COBOL because their all their unemployment data and all that was in the database, and they were using COBOL to access that. Right,
Yeah.
right. But that's one language which I guess not too many people know about. So Yeah, there have been many languages. Like I was talking about Pascal, right? So Pascal was actually very easy to use, and I liked it, but it went away. So a lot of these features have now been used in other languages like Python, and then there is another language called Julia, which is very new, and that actually is built to run for parallel code and also run faster. But it is not yet popular. So hopefully, if it gets popular, then we can create more new models and. Uh, you can see like Python has become very popular and people write models because it's so easy to use. People have been using it for, as I mentioned, in all these fields like the cell modeling and for air quality and even for natural language processing. People are writing image processing. They're writing all these codes in Python because it's much easier to use. But of course, underlying all these libraries is C library. So it's not pure Python, not Python called C to improve the speed. So, thank you.
Okay, good. We have a comment from YouTube. Actually, it's from Professor Untitled. Anyway, I would like to get the credit from Professor S because he introduced Dr. Chowdhury to us today, and he has a comment about I encourage students to try to get PhD like this. Okay, and I also noticed that your major is chemical engineering, both bachelor degree and PhD degree, right?
Right,
And now you're actually working on the data engineering. You are a data scientist,
right,
and you look at programming, data analysis. So when you change major, okay, so is there a does it take a big changes in your mindset? Because for me, my bachelor is computer software, and the master is computer engineer, and PhD is also computer science. So I didn't change my major that much. So I'm curious how, when you change major, how does it like? And also this will apply for the students here, right? Because not everybody has the computer science degree from their undergraduate. So
right. Well, it happens slowly actually. So it's all based on the interest, right?
uh-huh.
When I started looking at all the data from air quality, and then as I said, I did the source term estimation project, I started using machine learning. So I got very interested in that. And I found it very fascinating. So that's why it was very easy for me because I liked what I was seeing and started learning more about it. And the more I learned, I liked it even more. So basically, I just went ahead with that using air quality data, and then now I do meteorological data, weather data. So it's been a smooth transition, and I love what I'm doing. So
Yes, from you describe, I also see a common path. I see people from the physics, engineering, or chemical, or mathematics, right?
right,
Those majors, those areas, they deal with data heavily.
right.
And so that's why perhaps that is a good path to transfer to data engineering and science.
Right, right,
Right.
right. And I mentioned, right, like this machine learning or artificial intelligence, there are so many applications. So if you want to be in the healthcare, industry, or you want to be in the self-driving industry, or you want to be in uh, games, right, virtual reality or augmented reality or anything like that. So it's very good. So if you like that field and you know about it, then it becomes easy. So, if you want to transition, it should be something which you already are interested in and it has some overlap, and then you can slowly and have a smooth transition from one field to another.
Yeah, that's wonderful. Yes. So today so it's good to have Professor Poconi here. So Professor Poconi has been with ITU from the very beginning, and so he used to run IT events. So I always love to have him here, and I would like Professor Kokone to say a few words and ask some questions. Yes, so please unmute yourself. Professor Kokone, are you with us? Yeah, you can unmute yourself. So Professor Kokone, please unmute yourself.
Yeah, hello. I am Cornel Pocorni. I've been with ITU since a long time, practically since it was founded. And I have gone through many ups and downs with the university. And ITU has always survived and has provided excellent education to the students, and it's very sought after by employers in the Silicon Valley area. Now, currently, we have developed in the ITU, in computer science department, that's where I'm the chair of, we have developed 3 master's programs, and one, the oldest one is software engineering, and then later came computer science, and later came cybersecurity, all very important master's programs. And also, currently, practically already developed, approved by WASC, is a Bachelor of Science in Computer Science, a completion program. That means we admit students that have a so-called associate degree for transfer from a California community college. They come into that program without any further checking. And also other students that have some equivalent, something that's comparable to a United States bachelor's program. We are also currently developing a bridge program for students who don't have a bachelor's of science program who want to go into a master's program. And it's actually quite easy to do because we have all these classes from the completion program for the computer science bachelor, and we will put 3 or 4 of those together, of which the students take some, and they have to pass these classes. And ITU is really with its nuggets courses and so on the leading edge of the development of the state of the art, and we teach our students very useful things to find a job quickly and be useful in our modern technological society. So that's pretty much all that I have to say right now. Thank you.
Thank you so much. Well, today we are right on time. If you look at the clock, so we plan to finish the Q&A by 7:20. So I am still sharing. So am I still sharing the screen? Yes. So and we're going to take a quick break. Okay. And before that, I want to wrap up. So today, after the break, we'll come back for network, right? So it's all about capacity and relationship. And actually, Dr. Chowdhury, he mentioned about the importance to find network and extend the research and exchange ideas. But before we take a break, this is our fun moment. That's my favorite, okay? So that is, we're going to take a screenshot. Do you see this gallery view? And so it's time to turn on your video. Turn on your camera and sit out for the camera, okay? Wow, nice, Renzo. You responded so quick. And Kenan, and Fida, we're waiting for you. And Anna, yay, that's so great. So I'm going to say cheese, and then you all smile, okay? When I say, there's some delay, so when I say cheese, then you just smile right away, okay? 1, 2, 3, cheese. Okay, do we get it? Actually, it's good, but let's try one more time, okay? Since we are right on schedule, one more time. Okay. And one more time, actually it's not that bad, but we love to have a backup. Engineer always want backup. So 1, 2, cheese. Okay. It takes skill, in fact. Okay, I think we got it this time. Thank you so much. And so before we go, just remind, okay, gentle remind, this is a class, so we still need to do homework after the class. And this time, this is the third time that we only have 5 times. And so after the class, I'm going to upload the signature assignment. That's the final report. So get started and work on it. All right. And so let's take a break, and we'll see you in about 2 minutes.
YouTube தெரியுதுல ஃபுல்லா தெரியுதுல அப்படியே தெரியுதுல
Welcome back. Well, it's time to network. I know we have listened to our speaker. Our chair, Dr. Okoni and Dr. Panda, they all share their experience. So, what is missing in the whole picture? We want to get to know you, students, right? Okay, so let's all turn on the camera. Theta, Renzo. Yes. Theta. Okay. I think this is the third time. At the beginning, we were not familiar. You may be shy away, okay? But now, we hope you have enough courage to speak out. So where are you from, right? To speak out. If you notice, these 3 times speakers have all kinds of different backgrounds, right? This is diversity, and especially Chowdhury. I mean, he has very similar background as us, so we'd like to know where you're from, right? And what was your major when you were graduate, and then um, and right now your degree program, right? And most important, what's your dream? And after you learn about all those emerging technology and how your dream will shape, will be changed by these technologies, right? So we would love to hear about you. Who wants to come first? Okay. Hey, so I see smiles. So Keelan, do you want to try? Keelan, so you can unmute yourself.
Hello. Hi. This is Keenan, and I'm an MBA student, a business analyst. Thank you for the presentation. It was interesting because you mentioned something about a data analyst, and that's just the field I want to focus on. So yeah, thank you. It's pretty good and it helps me.
Yes. So to tell you a little trick, actually they were active. We have an online discussion after the talk. So usually they say, hey, I was trying to ask the speaker this question, and they were good questions. So I always say, why did you ask that ask the speaker directly, right? So now your field is very close to the speaker. So as a data analyst, so what is your biggest concern or puzzle? You know, is something that you were working on that if you have a mentor here, what would you ask for help?
Oh, okay. There's like one trouble I have. And you said about like you learn Python for the analyst for the statistics kind of stuff. Because I learned some of the Python on the online course by myself too, but the only problem is like how often do you use Python? Like, do I have to be like really master on it, or just like I just have to know the basic stuff, how to know the coding that is about the analyst field?
Right. In my experience, it depends on the company you are trying to join. So, some companies, like I tried to join a company in this area, and they asked me to do a coding interview. So,
Oh, okay.
yeah. So I definitely, I know Python and I know how to use it, and I have used it in my field. But when you start to try to code it in an interview, it's different, right? Because you
Yeah.
have to Google the syntax and you have to do it fast. So definitely I did not do very well. But then there are other companies which actually are not looking at your Python programming skills. They are looking at what you bring to the table, what your experience is. So, so depends on which company you're trying to join or where you want to work. But I would say that if you are trying to get a job in this field, you should definitely try to volunteer or join some of these groups, on GitHub, or do some of the competitions like the Kaggle competition, and that would help you understand or work with others, and you will improve your skills definitely. So I would recommend doing that. So, or at the minimum, you should go to GitHub, and you should look up other people's code in if you have pick up some problem and then try to solve it. You should look at GitHub and see whether some people have solutions there or not. So and maybe collaborate with them. So
Thank you for your advice.
Yeah. So those are so helpful because GitHub the beauty of GitHub is not the open source, right? In fact, the project you work on is also open source. You can
Right.
see everything. and learn from the best practice.
Right. Yeah. Yeah. So basically, there are a lot of even like the TensorFlow, right, which is the deep learning program, that's open source. So you can actually go to the GitHub or their website, and you can look at the whole code, and you can try to see how or look at some examples as how the people are using it, and you can learn a lot from there. So.
Alright. Okay. Thank you.
Yeah. Hayden, what major when you were for your undergraduate?
Business MBA, and then I saw the curriculum. There are some data analytics elective that I can take, and those are my focus.
Mm-hmm. So this is for your MBA, for your graduate master degree. But how about your undergraduate, so bachelor degree?
My bachelor degree, I took IT of business analyst again, but I think because my school was a business school, they didn't really teach much about Python or like R. It was like no coding at all. And what I find out is like business analysts require Python, some sort of Python. So, and I find data analysis also interesting, and so I switched my scope to the data analytics instead of just business analytics.
Okay, I see. Well, yeah, as long as you have passion on it and you like data. The beauty of data analysis in IT is a STEM program, right? So Dr. Carter, I mean, he's your chair. So if you have more questions, you can actually talk further. But before that, I want to give some time for Renzo, okay? Renzo, are you with us?
Yes, I am.
Yes. So tell us about your background.
Yeah, so I'm currently studying engineering management right now in ITU. My background before that is really in finance, so I do a lot of budgeting at PNA. But as I work in diversity and inclusion right now for internship, I really realized that I want to transition my career to something that is more related to project management. So yeah.
Okay. Well, Dr. Conda, you see, you have two students on here, and one from each department.
Yeah, I'm so glad to see them, and I recognize their names. So good to see on the video here. So Ranzo and Canon, thanks for joining. And if you have any questions, you can always ping me, email me. Happy to help with anything I can do from my side.
Yeah. Thank you both for your wonderful presentation tonight. Really appreciate it.
You're welcome.
Okay. Yeah, today, because we only gave Dr. Conda 50 minutes, so I actually pushed him a little bit. Okay, so we can invite him come back next time to talk about EM in more detail. All right. So, but I used to teach at the EM department, and I know it's an interdisciplinary between business and technology, right, and engineering. So from you, I mean, after you listened to this talk, is there anything that triggered your passion? Wow, this is something I really want to do. So, what's your dream?
Yeah, I'm still like in the process of really getting to know what I really want to do, especially with what's happening right now. We are facing a very unprecedented sets of occasions right now and sets of events. So I cannot say yes to that yet. I'm still like trying to know myself and what I want to do along the process.
Uh-huh. So, do you see any technology or application you have interest in? Is there something you want to learn further?
Oh, that's a great question. Right now, I've been trying to learn art by myself. Because I think it will just be like the next teacher, knowing how to code, no matter what your expertise is, or like no matter where you are, would be just very beneficial for your career. So yeah.
Okay, I see. In fact, because since Dr. Chowdhury has such an experience in data science, right? I want to ask you a question. Many people ask that, and it happened that Renzo mentioned that it's about two languages, Python and R, right? I mean, people have a lot of questions. I mean, which one we should use?
Well, it depends on your comfort level because R has been actually the which was first you has been used for data analysis for and statisticians and all have started using R. I think it came from some other language, but basically there were a lot of libraries in R earlier which was not available in Python. But the thing is, Python has become so popular that people have started adding a lot of libraries to it. And right now, both of them are equally good. So the advantage of Python is it's being used in multiple applications. So so it's up to you if you like R, and you want to learn and you want to use it, you can use it, and it's good. So if you want to do Python, that's also good. So, but you should just try out which one you think you're more comfortable with and which is easier to learn, and whether you can become more expert in one of those. So that if you get questions, you should be able to answer, be able to code.
Yeah. Okay, one thing I can share my experience. I use QuickLab. QuickLab provide lots of hands-on lab. And they also is from Google Cloud. Actually as a IT, if you have IT account, you should give you free credits. And I noticed that many labs from QuickLab, they use Python as what you said. They lots of library, right? So whenever they build application, they use library. And the best way to learn is learn from example. If they already build some good application out there, then you build from that. You look at the application, look at the requirement. You can change a little bit, and then becomes your own application, right?
Right. Yeah. Yeah, like all of these, I was talking about GitHub, right? So you have a lot of these libraries online, and you can actually suggest some improvement to the libraries, and you can contribute to it. So whoever is the team leader, if they like it, they can actually put it into the code. Or you can create your own branch, and then you can modify it. So you can do that with a lot of open source software. So
Yeah, that's wonderful. Yeah, see, this is a really very personal conversation, right? We don't get this much. Right now, we have a small group. Our plan is next, since in fall, then it will become a required elective class. So we expect maybe about a lot more students come in. But take advantage when we have a small group. Okay. So next, I want to ask Dida. Are you there, Dida?
Yes, I am.
Hey,
Hi, everyone's
how are you today?
good. Thanks
Okay.
for the presentation today. It was really good because I'm really into clean energy, like data analytics too. I'm digital art major. So oftentimes like we need to look at user data, and then like we need to analyze it, and then maybe sometimes we need to do some data visualizations, and then like make it in like much more easy way for people to understand how the data looks. um, I used to be a animator, like work on movies that like you see in the theater, like with all the visual effects. But then I changed my career path to like do UI UX design right now.
yeah, that's pretty good. Like as I said, I've worked at the hackathon with some of these,
Yeah.
and they came up with some really nice, unique projects. So it
Yeah.
was it was beautiful. So
Sometimes sometimes it's really hard to understand all the data.
Yeah.
Yes, so in fact, the beauty of digital art is I always said digital is 1 and 0. It can be so boring, right? But art, it's creative. We make sense of data. So
Yeah.
that's why I mean this is a very great combination. I mean when you look at the data, Google report, how can we make sense of it and then present it in different reports and different presentation. So this will be your niche. And you can see Anna is also from digital art. They have a lot of talent. So but today for Theta, you said you're also interested in data visualization, right?
Yeah, when I was in my bachelor, I learned some of them like they asked us to scroll like Tableau to see some like lots of different user data or different kind of data, and then we have to transform in graphic way so people can understand what is this data trying to tell us. Yeah.
So you have a good extension now, become a UI UX expert, right? You want to get in that area.
Yeah, that's it's all like about data too, because like we need to learn about how user like behave, and then like how do they interact with the app, and then we can do a better job on the UI and UX based on the data.
Yeah. So from that perspective, the data analyst is at the pipeline, right? So the last step will also need to present to the user. So
Yeah, that's more like the research part and like explorations to understand the insight, and then we can like work on the garbage part.
Yeah. So what kind of question you can ask? You have a mentor here.
Sometimes when I look at data, I'm really confused. Like different graph, and then sometimes I don't know where to start when I look at all this like graph data numbers. Like we are an art person. It's not like a like character or like all this data. I'm not like good at that. So every time I don't know where to start.
Actually, there are some examples. Like you can look at some different galleries. I don't exactly remember what the name of one of the websites is where they have, it's a commercial company, but they have some samples and galleries where they visualize the data in different ways. But in general, for example, if you go to Matplotlib, right, and they have a whole gallery, so you can look at the gallery and see how people are presenting the data in different ways. So you have bar charts, you have pie charts, you have scatter data, and you have there are different ways of presenting data, and you can get ideas from there and see whether you can use some of these examples as such, or you take multiple examples and then you create your own type of visualization. And then of course, as I was saying, you have 3D visualizations also, or use virtual reality or something like that. So I would say a Matplotlib gallery is one place, and then I don't remember offhand, but I think what was that high? Yeah, I think I'll send it to Michelle if I find that, and then she can send it to you. Or there are a few places where they have galleries. You can look at MATLAB also. MATLAB is again a commercial software, but they have galleries, so you can just look at the galleries too and see how other people present.
Thank you.
Wow, that's wonderful. One thing you can continue the conversation is we encourage you to connect speakers on LinkedIn, right?
Right. Yeah.
Then you can continue the conversation afterwards.
Right.
Okay.
Thank you.
And usually the speaker will remind, make sure you put ITU in your message. Then you remember that, or you say IT percent. Yeah, that will make you stand out. Okay, we have, Jen, she's also from India, okay? So, and she's doing the back end work, very hard work on the live streaming. So we thank her for her work, but she also wants to ask a question, all right? So her question is, if a student wants to excel in their careers, do they need to know multiple programming languages? So right now she's in the CS department, degree program, okay? So that's her
Yeah.
background, and she asked that question.
Yes, actually, as I said, it depends on what type of company you're trying to join. Some companies are very rigorous. Like if you go for an interview, they will ask you to do multiple coding interviews. So if you are actually going for companies which ask for coding interviews, then you have to be really good in that. So because it's time limited and you need to know, how to solve the problem or write the code within a given time. But it's good to know different languages like JavaScript. It's everywhere. It's one of the most popular ones. Then there is Java, which is also popular, and Python is also very popular. So some of the popular languages, which most of the companies are using, it's good to at least know them. And in my experience, if you know one language, then you can actually learn the other ones also, if you have the time. But the question is whether you can project that when you go for the interview. If you say that, oh, I know this very well, and I'm sure I can learn other languages, whatever language they're using, then it's good. But it depends on the company. So yeah, so it varies. So I think it's better to know a little bit about some of the more popular languages, and then you need to know a little more depth in some language. So you should be able to answer the questions.
Okay, very good. And so now each student, we have three students here tonight, but also we have Anna. She's the student assistant. She designed all the beautiful posters, right? So we love her. She's also from the digital art department. So we'd like to have Anna to introduce herself and ask questions. So Anna.
Hi, hello everyone. Thanks for the presentation. Can you guys hear me?
Video. Okay, put on your video, please.
Just a second. Okay, it's just because I'm on my phone. All right, can you guys see me?
Yeah, perfect.
Okay. Yeah, thank you. So as Michelle said, I'm a current VA student. I'm on my vacation now, so this semester I'm not going. I don't have classes. Next semester will be my last one for my graduation. It's been great. It's my first more technical degree because all my background is in business. So it's good to be working all those different tools for design. I'm glad to be helping SGA and IT Presents as well. So, and I'm glad that everyone is enjoying too. So actually my question is pretty much similar with Janan question regarding the language, if I wanna like excel my career, right? If I have to learn more than one, or if there is a main one that I could choose, so I could like, or if like if you consider my background, like DA digital arts, what would be like the best language I could go for?
For digital art, I'm not very sure about it, but of course, I'm biased towards Python, so I would say you should learn about Python because Python has been used in multiple fields. So and it's becoming really popular. If you look at the popularity, it's like Java, JavaScript, HTML, Python. So those are the top three. So actually, I would say HTML5, JavaScript. That's pretty good because if you are in design and all, then you have a lot of websites and other products which are using HTML5 JavaScript and all. So maybe that might be a good one. So
Alright, thank you.
Yeah, that's wonderful. I mean, this is really like customization, right? I mean, we get to know your background and we get to know your dream, and then we can give you some recommendation. That's wonderful. And we still have about 10 minutes to go, so this is great. Okay, the best time management session. So I know Jen is in the background, so she cannot unmute herself. Otherwise, we create echo. So we'll let her know. It's not like I don't want to let her talk. All right. And so Dr. Kanda, would you like to share more about your insight? Because we did not have enough time for you at the beginning, right? But then after the talk, so do you want to relay some of our program concentration with today's talk? That will be a good what we call it exchange.
Yeah, sure. I think one of the latest program we introduced, this is applicable to all departments, is a minor. Like the students who are in business administration or engineering management, if they want to do minor in software engineering, right? So you have an option, like you will talk to the software engineering chair, and they will suggest what courses you should take. 4 courses. If you do 4 courses, you will get a minor degree from the department. So vice versa. This is the latest what we introduced starting in fall. I think students, typically what happens is once they graduate and they start looking for a job and they realize, oh, they don't have some skills, right? So while they are in the school, it's the best opportunity to learn additional subject areas. That is a great way to learn. And also, as Dr. Pokarni mentioned, if you want to do, like again, I'm going to use business administration as an example. You have an MBA, and rather than minor, you may want to do another degree program, like a master's in computer science or software engineering, but you are very afraid to go because you don't have the knowledge or required experience in the programming, right? So as Dr. Pokarni mentioned, most of our departments have introduced the bridge program, where you will be prepared, like by taking the prerequisite courses, you will be prepared, like you will be obviously given the admission, conditional admission into the program, so your admission is guaranteed. Only thing is you have to go through those prerequisite courses, and then after you complete the prerequisite courses, you are into the program, like whatever the master's program you want to do. So the summary what I want to convey is, as the ITU, as the departments, we are collaborating a lot. We are trying to create the flexibility. We are trying to provide the opportunity for the students to gain knowledge from inter-departments. So when they go to the university, they are ready for the employment. So that's what I want to share.
Wow, that's wonderful. Yeah, I like it because you said, I mean, when you choose minors, you don't need to be afraid if they were admitted because you're already in, right? So that's the flexibility, and we have so many different bridge programs, and also concentration. Dr. Pocconi, we have a new concentration in AI, right? And that concentration will have we have courses that's in the data analytics. And so would you like to introduce that AI concentration and minor? The AI is also can be a minor as well, right?
I don't know in which masters the concentration exists. we don't have a concentration in AI. No, we have not yet introduced that.
Okay, yeah.
Where is it made? Is it in digital arts or is it in, I don't know where it is.
It's from,
Yeah, I think it's in the W program. It was recently introduced.
Oh, yeah,
Dr. Jahan introduced the concentration. Yeah, I think as far as minors, again, the students should reach out to the chairs, department chair, and they will advise what courses they should take. Like if you want to become, if you want to take a minor in software engineering, you reach out to Dr. Kulkarni. He will advise you take these 4 courses over the time while you are in ITU. So not only you get MBA degree, but also minor from the other department.
Yeah, we have another feature which is a little less stringent, or what is a slow small beginning. If a student is in some major program and wants to take an elective class in some other major, they can do it. It's basically allowed. But if the elective is really in some other department, in some other master's program, then the student has to get the permission of his own department chair, and then he or she can take that elective course. So a student can get a taste of how things are in some other major program.
yeah, that's wonderful. Well, we have 3 minutes left. I think today we have time to let everybody introduce themselves and talk about themselves. So I want to try something new today. Is Dr. Chowdhury, would you use 2 minutes to wrap up the takeaway? Just to wrap up for today's talk. Then we conclude this.
Sure. Sure. I would say that technology keeps changing, like as I was saying, and there is always new technology coming in, and there are multiple applications, and you can always find something which you like, and you should try to go into a field which you like and love to work in, and you should be willing to learn the new technology and also apply it. So that's my takeaway.
That's wonderful. Okay, we still have 1 minute. So, Dr. Kanda, would you give us a takeaway? Yeah, we want to use the time.
Yeah, definitely. While we are on this, I think I really liked Dr. Chowdhury's presentation, and also his personal strides, the challenges he went through, and where he is now, very respectable, very high profile position. I think it shows the determination and also the commitment, and that is what the main important thing. Don't worry where you are at today, but where you want to be, and you can always reach to that level. I think that's a big lesson learned. What I could see from Dr. Chowdhury's background and the commitment, inspiration.
Wow, that's wonderful. I want to say thank you so much. This is a great opportunity for us to reflect, inspire, and embrace the future. Again, thank you so much. We'll see you in 3 weeks, okay? So thank you so much.